All right, so today we want to look at getting the rate of change. And if you remember back when we did this by graphing, we could take any graph like this and we could pick a couple of good points on it. And if we wanted to know the rate of change, we would just take how far we go up to get from one point to another. We usually call that the rise, how much we go up by, and divide it by the run, how much we go left and right by. So in this case, first thing I'd say is that this is a graph that's going up, so it's going to have a positive rate of change. And then we would just count. We could just say, well, it's going up by 1, 2, 3, 4, and over by 1, 2. You could say, okay, it is rising by 4, and it is running by 2. And so the rate of change, which we usually use the letter M for, not really sure why. That's a good Mr. Calford question. But we could say the M is 4/2. And of course, if we want to, we can always actually put that into a calculator and turn that into just a single number. You can leave it as a fraction. Nothing wrong with that. But as it happens, you can probably do 4 divided by 2 in your head. But anytime you couldn't do it in your head, you could just use a calculator, and we'd know that the rate of change then in this case is 2. I kind of like the fraction. Nothing wrong with the fraction. But you can also put it as a decimal. Nothing wrong with that. So that's how we find rate of change. And you did a lot of that in our last cycle, and you guys got really good at it from what I could tell. So now we want to look at how do we do that same thing if what we have is a table of values. So here's a table of values, and the question is, how do we find a rate of change? Well, if you look at a graph, we typically call this axis, the one that goes up and down, the y-axis. And we typically call this axis, the one that goes left and right, the x-axis. And that's meaningful because if rate of change is just knowing how the up and down changes and dividing it by how the left and right changes, we can do that same thing from a table of values. So I've isolated this table of values just here, just so we can look at it a bit more clearly. But we can say, remembering on a graph that this is the y-axis and that is the x-axis, this y involves going up and down, and this x involves going left and right. That's just how the axes are named. So if the rate of change is what we call rise over run, which again, I don't always love that wording, but really it's how much we have to go up or down to get from one point to another, divided by how we have to go left or right to get from one point to another, then we can just do that right here on the graph. So the way we do that is just by looking at any 2 points we want. And it doesn't matter which two. I'm going to pick these two. And we just want to see how much are we rising by. To go from here to there, what's the change? And to go from 4 to 6, well, 4, 5, 6, that's up by 2. You can always just subtract them. You can count up on your fingers. But this is going up by 2. And this over here is going up as well. This is the run. And 0 to 1, that's easy. That's going up by 1. And so when we go to find the rate of change, which again we use the letter M for, we can say that the rise in this case is 2. And the run in this case is 1. And you could leave that as a fraction. That's a perfectly reasonable answer. So we could just say M is 2/1, rise by 2 and run by 1. Or if we like it better, we can actually do that division. And this is one you can definitely do in your head. 2 divided by 1 is just 2. These are both perfectly fine answers. And there we go. And it makes no difference what 2 points you pick. Let's say I had chosen to go from this point to that point. Well, here, from 8 to 12, if I count that out, 8 and then 9, 10, 11, 12, that's plus 4. You can't see me, but I counted that on my fingers. And down here, from 2 to 4, well, 2, 3, and then 4, that's going up by 2. I could have done the exact same calculation using those numbers. I could have said M is equal to rise over run. And then I could have said, well, in this case, we rise by 4 and we run by 2. And you might think, well, wait a minute, that's a different number. But rising by 4 and running by 2 is actually the same thing as rising by 2 and running by 1. And you can always prove that because if you do the math on a calculator, we actually do 4 divided by 2, we get 2. So we could say, or m equals 2. And of course, that's the same answer there. So it doesn't matter which points you pick. To make things less confusing, I'm going to just put one set of answers on here. But when you go to find the rate of change from a table, you can pick any pair of points you want. And if it's a linear relationship, you're going to get the same answer. All right, there we go. So let's just try one more together, just to make sure we can. This down here will create random questions for you. And I am going to cut and paste a picture of this just so we can write on it, because you can't write on that as it is there. So here's our table, and we're going to find the rate of change. And then we'll go put it into this box here. But here we go. We're going to find the rate of change. And again, the rate of change is just rise divided by run. So let's take a look here. What do we rise by? Well, hopefully you remember that the axis that is the up and down axis is the y-axis. We're always going to look at that one first. And we could pick any 2 points. Just to prove a point, I'm going to go from here to there. From 8 to 16 is rising by, if I can't do that in my head, I can count out. 9, 10, 11, 12, 13, 14, 15, 16. I count on my fingers, that's going up by 8. You could subtract the 2. You can just know your addition facts, whatever works for you. So we can say in this case we have a rise of 8. And then for the run, we can just do the same thing here. And we can say that runs by 5, 6, 7, 8, runs by 4. This is a really boring one because it happens to have given us a rate of 2 again. I might do one more after this, just to show you. So the answer would be either m equals 8 over 4, you can leave it as a fraction, or you can actually do that division on your calculator. And if we actually do that division on a calculator, 8 divided by 4 is equal to 2. So we could say m equals 2. Okay, I got to do one more example because I can't leave you thinking that the answer is just always 2. So if we look here, this rose by 8, it ran by 4, and so the rate of change was 8 over 4. It's going to calculate that out to 2, and that's the same answer we get. Okay, let's make a new question. Oh, I kind of like this one. Okay. So we'll copy that. And we'll go down here. Here's another question. I like this one because it's going down. So again, we can say m equals rise over run. And so we can say m equals, and we'll show rise as green. We'll show run as yellow. And if we look at this, when we go to get the rise, I'm just going to go from this first point to the second point. From -2 to -22, well, that's changing by 20, but it's not going up by 20. This number is getting smaller and smaller. We're getting more and more negative. If this were money, we'd be losing money. Your bank account, hopefully your bank account doesn't look like that. So this is going down by 20. This is a line that goes down. If we were to graph this, it would look like this. It would be a descending line. So the rise is -20, and the run is from 0 to 4 is going up by 4. So the rate of change is 20 over 4, and you could leave that as a fraction. There's nothing wrong with that. That is a slope. But it's always kind of nice to actually do the division and get this as a decimal. 20 over 4 is equal to 5. So we could say the rate of change is 5, which means every time we change by an x, we go up by 5. And if we put that in here, we should get the same answer they do. So we said rise of -20, a run of 4. Oh, ooh, I got to be careful. So that needs to be -20 over 4. And -20 over 4 isn't going to be 5, it's going to be -5. Just like that. So there we go. And now I can put that in here and I can check our work. The rate of change should be -5. Check the answer. And yeah, there we are. We got the same answer. And when I get a right answer, I can do a screen snip of that. I'm going to paste that into this spot because that's what this question asks us to do. And I think it wants you to do 5 of those just to make sure you got it. So do 5 of those to make sure you got it. And then you can be confident that you know what you're doing. All right, thanks guys. Talk to you later.